Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Sla YouTube channel. So today in this video, we are going to see about the very basics of the Java, and the reason behind watching this is or the video, the posting the video is we are going to see about how the JVM works, how the garbage collection works in our upcoming videos, and this is going to be a huge set of videos. So please don't forget to subscribe to our channel to watch all the videos. And we are going to discuss starting from the architecture and how the JVM works and how to improve the performance using the JVM. And all these concepts are going to be discussed in this set of videos. So we are going to have like more than another 50 days. For next 50 days, we're going to have multiple videos on it. So please do subscribe to our channel and don't forget to join my channel for more continuous and quality content like this since I'm making videos on daily basis. So please do consider joining my videos and share the video with your friends. So when coming to the Java technology, so the foundation of the Java technology is the Java virtual machine. In fact, I would say that the heart of the Java technology lies, or I would say the Java virtual machine lies at the heart of the Java technology, which is an abstract computer on which all the Java program runs, where the JVM serves as the runtime environment for all Java programs. And this virtual machine enables the Java applications to be executed, providing the essential infrastructure that allows the Java code to run consistently across different hardware and operating system. And that's why we all boast that the JVM runs on different hardware on different operating system without even making any changes, and that is being possible only because of the Java virtual machine, because it provides that essential infrastructure. And this again is the abstract of the computer, I mean the abstract computer on which it allows all the Java programs to run. And then the next part is the Java programming language. So we'll see what is a Java programming language and what are the other components of it. So the term Java is commonly associated with the Java programming language, but the Java encompasses more than just the language itself. And here is a breakdown of the key components that together create the Java ecosystem. So firstly, we will see about the Java programming language, and this is the mix of the syntax and rules that are used to write the Java code. So which we all know that it's what most people think of what when they hear the word Java. And then the second part is the second component is the Java virtual machine, or we commonly call it as JVM. So this is a virtual computing environment that allows the Java programs to run on any device or operating system. And again, like I told you in my previous slide, that the JVM lies at the heart of the Java technology, and this JVM translates the Java bytecode into machine code that the host system can execute, and in fact that's the only thing it can understand. And then this third component, or the next one, is the Java API, which is the application programming interface. And this API is a vast library of pre-written code that the Java developers can use to perform common tasks such as data manipulation, networking, and graphical user interface design without having to write all the code from scratch, because they are more reusable. So you can use it for networking, you can use it for your graphical user interface design. So all these can be they are like pre-written, we can readily use it. And then the last one is the Java class file. So this is a compiled Java file that contains the bytecode which the JVM can execute. And this is the result of compiling the Java source code, and it is what actually runs on the JVM. So the Java class file is, again, it's just a compiled Java file which contains the bytecode which the JVM can execute, right? And that's the result of the compiled Java source code, and it is what actually runs on the JVM. So all these components work together seamlessly, and the developers write Java programs using the Java language, which are then compiled into class file. The JVM execute these class files, and the Java API provides a wealth of ready-to-use functionalities to streamline the development. And this integration of the language, the virtual machine, the API, and the class files make Java a powerful and versatile technology. So this the reason behind discussing all these points is like the more you understand the basics, it will be helpful for you to learn the most difficult concepts. And moving on to the next part, which is why JVM or why Java. So over the ages, people have used tools to help accomplish their task, to complete their task. But lately, their tools have been getting smarter and interconnected. We all know that our tools are getting smarter and they're getting more interconnected. So microprocessors, the one that you see in the picture here, the microprocessors have appeared inside many commonly used items, and increasingly they have been connected to networks. So, as the heart of the personal computers and workstations, for example, the microprocessors, like the way the boy is attaching the microprocessor to a system, so it has been routinely connected to networks, and they have also appeared inside devices with more specific functionality. So, so nowadays, the more they become smaller, they become more powerful with more specific functionality than the personal computer or the workstation. So, we have various devices that are connected to the system, and every single device has its microprocessor connected to it. So for example, the televisions, the VCRs, the audio components, the fax machines, scanners, printers, cell phones, the personal digital assistants, the PDAs, the pages, or even the wrist watches, all have been enhanced with microprocessors, and most have been connected to networks. And that's, we all know. So these microprocessors were of, like, they were having a huge potential, and they were having a huge implementation in all these tools and in all these machines and their networks. So, given the increasing capabilities and the decreasing cost of information processing and data networking technologies, the network is rapidly extending its reach. So, the emerging infrastructure of smart devices and computers interconnected by networks represents a new environment for software, an environment that presents new challenges and offers new opportunities to software developers. So, Java technology is a tool which is well suited to help you meet the challenges and seize the opportunities presented by the emerging computing environment. So, since Java was designed for networks, its suitability for networked environments is inherent in its architecture, which enables secure, robust platform independent programs to be delivered across networks and run on a great variety of computers and devices. So moving on to the next part, which where we are going to discuss about the challenges and the opportunities of networks and why Java has emerged out of all the other technologies. So when telling this with an example, so in a networked computing environment, the developers face the challenge of accommodating a variety of interconnected devices, so each with different hardware architectures, the operating systems, and functions. For instance, consider a large company with a diverse IT infrastructure, which includes Windows desktops. They might have their applications running on a Linux servers, Mac OS laptops used for development, and they have various other mobile devices to connect to develop their applications. So, traditionally, developing a new internal messaging application for this environment would require creating separate versions for each operating system, which you all know. So previously, a few years back, if we want to create an application for multiple operating systems, we have to create separate versions, which leads to increased development costs and complexity in maintenance. But Java addresses this challenge by enabling the creation of platform independent programs. A single Java application written once and compiled into bytecode can run unchanged on any device with a Java virtual machine. And like I said, again and again, I'm saying the same point. The JVM is the heart of the Java application, and this approach simplifies the development and reduces the cost, as there is no need to maintain multiple versions of the application, and the updates are made once in the Java code and apply universally across all the platforms. So that's again a very big advantage of it, and which ensures a consistent user experience. Thus, Java's platform independence makes it easier and more cost effective to develop, deploy, and maintain software in a network computing environment. Another challenge for software developers in a networked environment is security, as networks can be exploited by malicious programmers who steal or they destroy information. So, for instance, the virus writers can distribute harmful programs for users to unknowingly download. And Java tackles this security issue by offering a secure environment for running network downloader programs. And these programs operate within defined security boundaries, which allows them to function without accessing or modifying data outside those limits. And this customizable security framework helps protect against potential threats and ensure safer execution of applications. So, on top of the enhanced security and productivity, Java prevents bugs like memory consumption, memory corruption, and they ensure stable and reliable code. And this robustness saves developers time on debugging. So, for example, Java excels in its online software distribution, which transmits small binary code pieces across networks. And this makes delivery easier and cheaper and simplifies the version control. And because of this, the user always receives the latest version of a Java program, which ensures consistency and up to date functionality. For instance, a company can update all their users with the newest version of their Java application every time it's accessed. And this actually will benefit from the most recent updates and features because, like I told you previously, the Java compilation or the compiled code helps you to distribute across all the environments and across all the hardware architecture. And then to end this part, which is in terms of the challenges and opportunities, so the platform independence, security, and the network mobility are the three key aspects of Java's architecture that make it ideal for the evolving networked computing environment. And Java's platform independence allows software to be delivered across various computers and devices connected to a network without modification, and this uniformly simplifies the distribution process. Additionally, Java's built-in security framework enhances the practicality of networked delivered software by minimizing the risks and thereby fostering trust in the concept of network mobile code. So with that, I come to an end. And to know more about, and I mean, in fact, in the next video, we are going to see about the architecture of the architecture of Java, and we are going to see what is compile time environment and what is runtime environment, and we are going to see about what is a Java virtual machine, how does it work, and a basic block diagram of the Java virtual machine. So, like I said, to watch more and more videos on what is Java virtual machine, please do subscribe to our channel, and we are also discussing about various other tools as well. So please do subscribe to our channel. Consider joining my channel for more informative and quality content. So until I meet you in our next video, it's bye bye from Vasan Shanmugam and your favorite Little Star YouTube channel. Take care and bye bye.